Hi, this is Grant from CNC, and I'm doing some more air conditioning videos here. So this time I'm going to show you how to do a recharge and maybe get some ideas out of the way of how to use a machine to evacuate, to charge a system like I'm used to doing, which is to create a huge vacuum in the system and then allow that vacuum to pull the refrigerant back into the system, and then how to check the pressures once you're done. We're going to use the simulator board that we have here, and I've got it running right now, so maybe we can take a quick look at the pressures that we're running. In a vehicle, the fan can cut in and out. This system has the fan running all the time, and our evaporator over here is cooling off or removing the heat from the cab, and this condenser is actually trying to release that heat once it gets out in front of the radiator. So this is a simulator set up so you can see all the components in an air conditioning system, but it's not exactly how it would be laid out on a vehicle. So I'm going to show you a few more components with me behind the camera. Hang on a second. This is our Robinair recovery system we have, and I've got the power on. You can see the lights on and that sort of thing, and hopefully I'll be able to show you what comes up in the screen all the time. You can see the bottom of the screen has some simple buttons like a automatic, recover, vacuum, charge, and then the next button. We'll be using this. Right now it's telling us that the tank has 13.72 pounds in it, which is the tank down below under here, which I have turned on, and it is sitting on a scale, and that is how we tell how much refrigerant is actually in a system. We can't tell how much AC refrigerant, or R134, which is what we use in today's stuff. There is a newer one, but we'll talk about that in class. This is a R134 system operating right now, and you can see the red and the blue service ports here. So if I were to take the that's cool. Okay, so these would be on a vehicle, and you can see they're two different sizes, and the Schrader valves are inside them. And that's what we're going to hook our machine up to, our Robinair machine. Okay, those are the service ports. In my last video, I didn't show a lot of close-ups of this simulator board and all the components and phases of an air conditioning system. So I'm going to do that now. And I'm going to start with the compressor. The compressor's down here, or simulated compressor is down here. There is a compressor acting on it, and it is working on the inlet and outlet. So it's going to take the low pressure vapor coming out of the evaporator is getting drawn into the compressor with the pistons and reed valves, delivering it out the other side up to our condenser, and it's trying to turn it into a liquid. That compressor will be compressing the liquid, making it hotter and making it into a liquid state, trying to get it into a liquid state. As it goes through the condenser, works its way down that heat exchanger and comes out the bottom, it will be coming out as a liquid. That liquid is going to go up and come out of the condenser. It has now been condensed into a liquid and will come up that line across the top, just because that's how they lay it out. This is the high pressure side, you might notice. Okay, and then to the receiver dryer. The receiver dryer has some refrigerant in it, and it is drying the refrigerant with the desiccant that's in it. Okay, it'll come out through there and head down to an expansion valve. That's not a typical looking expansion valve. Usually they look like a pack of cigarettes with a bulb on the right hand side that sends or receives information about the temperature of the outlet of the evaporator. Okay, we've got our evaporator, we're evaporating. It's a liquid now that it's come out of the condenser, and now we're delivering it as a liquid to our expansion valve, and that expansion valve is going to send it through an orifice, and that's going to send it, start changing it into a gas as it moves up through the evaporator, evaporating and absorbing heat out of the cab. It takes that absorbed heat out of the cab and then comes out and goes down to the compressor, where it is pressurized and then turned into a liquid in the condenser. It condenses from a gas to a liquid in the condenser, and it turns from a liquid into a vapor in the evaporator. Okay. Also, while we're running it here, we've got a fan going and we've got the compressor working, so we can look at our pressures in the system. So our low pressure side, which is the blue gauge, is running about 26 psi, and I believe what the rule is probably 12 to 20 psi is normal. So this one's running a bit high. Not anything to worry about for my way of thinking. You can notice that there's a green section on that gauge that allows it to measure inches of mercury, which is the vacuum side, when we start doing an evacuation on this system. The high pressure side is the red gauge, and you can see it's reading, if you can see, it's reading about 150 psi. So that 150 psi is what that compressor is making. It's making that pressure through a restriction through the system, and that is making it hotter and trying to turn it into a liquid. Okay, so the high pressure, low pressure side. The low pressure side consists of the evaporator. It consists of the expansion valve, or part of the expansion valve, because it comes in as high pressure and leaves as low pressure. And then also in the low pressure side, it comes out and goes to the compressor. So that coming out all the way, the compressor is part of the low pressure system as well. The inlet is low pressure, and the outlet of the compressor becomes part of the high pressure side. The high pressure side goes into the condenser, down through the condenser, and then out and over to the receiver dryer. The receiver dryer is part of the high pressure side, and as we go across, it comes down and goes to the expansion valve, which is also part of the high pressure system. So the expansion valve and the compressor are both parts of the high pressure side and the low pressure side. Okay. These are the connectors from our Robinair tester. Okay, they come out of the machine, and they are what we use to test a system. Systems like this do not have gauges on them. We need to use the gauges from our Robinair tester to measure the system, okay? So for our purposes, it works really well because we have gauges on them, but when we're hooking up to a system, we need to use the gauges on a Robinair, or else a gauge manifold system that most people have as well. It's a lot cheaper than one of these things, but anyhow. So I pulled the caps off of the service ports. I have a high pressure service port that's high, that's big, and a low pressure service port that's small. So this is the red hose, the red connector, and the high pressure side. I can put that onto this side, and then I tighten up the knob on the end of the fitting. This will complete that, and I can start watching the pressure in the Robinair. This is the blue low pressure side, low pressure blue hose, and it goes on to the low pressure connector, which is the smaller connector, okay? In the old days, we ran R12. Look at this R134 system, and we can see that it's got, it should take 28 to 32 ounces in this system, okay? I've now shut the thing off, but if I wanted to, I could still run this and see what the pressures were being built in the system. Okay, so I could troubleshoot maybe a restriction or a problem. One of the biggest restrictions tends to be the expansion valve down in this corner. The expansion valve is the orifice that the refrigerant goes through. So it becomes it tends to be one of the hardest things to keep operating well, because any debris or imperfections in the refrigerant will actually plug that up. Okay, so now if I wanted to run it, I could. Right now I'm looking at about 100 pounds on my high pressure gauge, and I'm looking at about 55 pounds. If I left that alone, these both would stabilize and become the same amount, because the system, although being a closed loop system, it is open to each side at all times. So it will always equalize over time, and you will know what pressure you're running in your system. The pressure in the system does not mean the amount of refrigerant in the system. The amount of refrigerant in the system can only be measured if we pull it out and put it into our Robinair tool or air conditioning recovery system, okay? So we need to put it into there, and we'll actually weigh it and know how many pounds we've got into it. It is measured in pounds or ounces or kilograms or milligrams, but we have to know what kind of refrigerant we have in our system before we can pull it out. This recovery system that we have here is for R134 only, okay? If this system had Red Tech or maybe an R12 or an R22 from a refrigeration system, I've even heard that down in Mexico and places, they use propane as a refrigerant, which is an excellent refrigerant. A little scary if you light a cigarette and you've got a leak in the cab. I would think that would be a little dangerous. But anyhow, it's for us up here, R134A is the stuff, and I think it's called R1234Y that is out now. So, and it is very, very close to R134A. Anyhow, so what we need to know is what it is, and they make refrigerant detectors that will tell us that. I'm not going to go into that today, but anyhow, the refrigerant detector will tell us what kind of refrigerant is in it, okay? I'm going to recover the refrigerant out of it, okay? So we figure out the type of refrigerant, then we're going to recover it, okay? This thing has a holding tank for it, and it will weigh it as we pull it out, okay? So we can recover, reclaim, recycle, or reuse, okay? So reusing means we take it out, put it into our Robinair, and then let it, and then just put it back into the system without doing anything to it, okay? Reclaim means it's destroyed itself. It has been, if you have a receiver drive that the desiccant comes apart in, or if somebody's got a bunch of moisture into the system and it's wrecked that refrigerant, you have to actually send it to a depot or a chemical processing plant to remove all the problems from it. Or to chemically break it down and remake it into something else, or destroy it so it doesn't hurt our ozone layer and create greenhouse gases. So that's what reclaiming is. We basically put it into a dirty tank and take that dirty tank and we give it back to Dow Corning or whoever the chemical company is that would take care of it for us, and they would destroy it for us, basically. Okay, so that's what reclaiming is. Reusing is just taking out and putting back in. Recovering is simply what we're going to do right now. We're going to just take all the refrigerant out of it, put it into the tank, measure it to see, maybe we've got a problem with this and it's not blowing cold enough air. Maybe the pressures are too low, and we want to know if this is because it's got a leak somewhere, right? So we've got to recover it, put it into the tank, say, oh, hold it, we've got a low charge. At that point, we can weigh it and we'll know what the charge is. And we will save that. And then recycling is what this tool does as well, okay? I'm going to try and do this move. Okay, so this tool over here will recycle it as well. It takes it and runs it through a filter and through an air dryer, or through a dryer, a desiccant, and then it's ready to put it back into the system. It removes all the moisture, removes any debris it has in it, and then it's ready to put back in the system. This is quite a marvelous little piece of machinery. We didn't have anything that nice when I was young and starting out in this, but anyhow. Okay, so I've hooked up, and now